Welcome to the Yugabyte webinar on evaluating PostgreSQL compatibility in distributed SQL databases. This is a hot topic that's gotten a lot of attention in recent weeks, months, as more and more distributed SQL databases have been talking about PostgreSQL compatibility and how compatible they are. So it's a deep dive topic. There are lots of topics to cover within this broader, umbrella of PostgreSQL compatibility. And we can think of no one better to discuss this in depth than Karthik Ranganathan, our co-founder and CTO. Karthik is going to provide a framework around how to think about PostgreSQL compatibility, what it means for you as a developer if you're thinking about Postgres compatibility and how it applies to your applications and so on. One of the things we had done before this webinar was we had solicited questions from the community around what they would want to hear, because we wanted to make this a virtual discussion where we answer the questions that people have about PostgreSQL compatibility and what it means for them. So we've got a few write-in questions that Karthik will be covering. But of course, if you have additional questions that you want to cover, definitely put them in the chat or put them in the Q&A. We have time set aside at the end of the webinar to get into those questions in more detail. With that, Karthik, I'll turn the floor to you.
Thanks, Sudha, and thanks everybody for taking the time to attend. Yeah, let's jump right in. As Sudha said, just to set a little bit of context, right? PostgreSQL compatibility is becoming a big thing. I mean, a lot of you that are attending this talk probably already know why, but for the others that are thinking about why does compatibility matter, and you might just love Postgres, well, that's precisely the point, right? There's a lot of usage of Postgres going around, and a lot of databases starting to support Postgres. Okay, so all right. So the reason why we should all care about Postgres is, firstly, it's becoming the gold standard for operational databases. The adoption of Postgres by any measure is totally on fire and has been growing rapidly. So if you look at the DB Engine's ranking, it just keeps climbing year over year. It's been named the database of the year for multiple years, like in the recent few years. Hacker News votes it as one of the most used databases, most loved database, most wanted database, or whichever way you look at it, Postgres is definitely getting its adoption, right? And if you take a second to think through why, right? Like, why is Postgres awesome? What makes it awesome? Well, the first thing is it absolutely has a spectacular set of functionality that it provides as a database. And it already has a huge set of features, and it's more and more get added every year. And Postgres itself is more than just a relational database. It supports a lot of post-relational concepts, right? Like things like in-database functions. Like when you think of a relational database, a lot of folks think of ANSI SQL compatibility, right? Like our ANSI SQL compliance. Well, it does a lot more than that. Like in-database functions, user-defined types, full-text search, graph querying and recursive queries in order to support graph-like access patterns, time series support, document data type and queries on document data type, and a whole lot more, right? So it's really functional for a wide set of use cases and applications. So it forms a great database to start with. Postgres is very robust. It's got the performance and speed, the security, the reliability that makes it very, very suitable for a variety of applications. Postgres is insanely extensible, right? Like it's got like extensions. You can write modules in other programming languages or SPI without having to recompile the database. So you can actually invoke your own code and get that to execute as a part of the Postgres database itself at the right times, right? And Postgres is open source. So all of this goodness comes at no cost. You can take it and do what you will with it. And the community just keeps adding so much value that people usually gravitate towards the fully open offering, right? So this makes PostgreSQL the API of PostgreSQL and whatever it supports, very important for the new databases that are coming up, right? Well, because new databases are trying to get to the same spot. I mean, there's a reason why people build a new database, and the reason why needs to reach a lot of people and needs to get a lot of usage in order to satisfy that need. And that comes up in terms of getting more developer familiarity. And the Postgres API it has a lot of developers using it. And a compatible API is the easiest way to tell a developer, look, it's just like Postgres, except it does these other things, right? Like it's very easy messaging, right, for the developer to adopt. Similarly, Postgres has a proven set of comprehensive and robust features. So if you say, look, I am Postgres compatible, people then think, okay, I know the type of features that you would do support, and I know what I can expect from the database, right? And Postgres has ubiquitous adoption. There's a lot of new applications, frameworks, and services being built on Postgres. Adoption is on the rise, which means the tooling and the environment, the support for it, the talent pool of people that know how to use Postgres, everything is on the rise. And so that de-risks picking up a database that is Postgres API compatible, right? So Postgres compatibility is a no-brainer for a database trying to offer a unique new feature set in order to accomplish an end, right? So, it's no wonder that you're seeing more and more databases becoming Postgres compatible, right? If you look at Amazon Aurora, right, it's Postgres and MySQL compatible. If you look at CockroachDB, they have a familiar, consistent SQL. All of this is from their respective websites, right? So you use a language you already know and tools you love with Postgres compatible SQL syntax, right? And then if you look at YugabyteDB, it's get instantly productive with a Postgres compatible RDBMS. So even very recently, just back in October, Google Spanner announced PostgreSQL compatibility as well, right? And if you look at Google's own message, right, they do call out that Postgres has emerged as the API for operational databases. It's mature, open source with a large growing ecosystem and other stuff, right? So the point is everybody's recognizing it. Everybody is adding some type of Postgres compatibility to make it easier for people to get onto their database and use it for the design point for which they built that database. Okay, so we talked a lot about Postgres compatibility, but what exactly is Postgres compatibility? And if different databases say they are Postgres compatible, does it mean the same thing, right? Which brings us to the core of what we're here to discuss, right? So here's a framework, right? So jumping right in without too much of a buildup. So here are 4 levels of PostgreSQL compatibility, right? Let's look at what they are, and then we'll talk about why these 4, right? Why the framework with these 4. So when you talk about Postgres compatibility, the first thing you can think about is wire compatibility. Well, that means the Postgres database reads some set of commands, queries, etc., structures off the network, which are written in some sequence of bytes. They're serialized in a particular fashion, right? If the database that we're talking about, the new database, can actually understand the same sequence and serialization of data that Postgres understands, then you call it wire compatible. Now, what is the advantage of wire compatibility? Well, it means that you can use your Postgres client drivers in order to talk to the database, the new database. So that means you're pretty familiar with how to get an application to communicate with the database. And you're able to write your application in a variety of different languages, like Java using JDBC or Go or Ruby or Python or what have you. And you can use the command line tools like PSQL, which is the Postgres command line tool, to connect to the database and explore, list the tables, list the schemas, select and run queries, modify data, so on and so forth. And developers can start building a simple application with ease because they already know how to write to Postgres, and writing to a database that's wire compatible with Postgres involves the same set of steps on the application side, right? So that's wire compatibility. That only talks about how you serialize the data and send it across. Next over to the right is syntax compatibility, right? So now, okay, you can already use the client drivers, but can the database parse the same syntax that you would use for Postgres? So in other words, if you took a snippet that looks like a valid Postgres snippet and send it to the database, would it be able to create a table or execute a SQL statement and return a valid result? The actual way it executes could be different. Like you could give it some extra parameters. It may simply ignore those parameters. There may be some other statements that it understands but executes differently. We'll come to that in a different form of compatibility. But here we're simply talking about if I create something that looks like PostgreSQL in terms of syntax, SQL syntax, will it work, right? And this now extends the compatibility to the next step where developers can now start using some of the Postgres tools and some of the frameworks because they would send those type of commands and the database actually understands what to do with them, right? Then comes the next level of compatibility, which is feature compatibility. We already talked about Postgres being so powerful because it supports not just ANSI SQL, but a lot more, right? So it's critical to be able to support more than just this ANSI SQL set of features. That's what makes Postgres so powerful and so loved. So how many of the advanced features of PostgreSQL beyond ANSI SQL does this database support? And some of the examples are things like triggers, stored procedures and functions, row-level security. There's a whole bunch of these. Now, in order for somebody to leverage some of these features in this form of compatibility, you don't need the equivalent feature to work exactly the way it works in Postgres. You just need some equivalent. Like, for example, I use a trigger for something. I need to be able to accomplish that same thing in the new database. And how would I do it, right? So that's the next level of compatibility. However, this means if it's different, it means that developers would need to relearn the equivalent and think through any gotchas, caveats. Does it work for all their use cases, and modify their apps accordingly, right? And then finally, the fourth form of compatibility is runtime. It matches the Postgres execution semantics at runtime completely, right? And it automatically implies all the other forms of compatibility. You need wire compatibility, syntax compatibility, and to some degree feature compatibility in order to be runtime compatible, right? In order for an application written to Postgres to be able to run against this database, you would need all of the others, right? And developers that know PostgreSQL will completely be at home from start to finish if a database supports runtime compatibility of PostgreSQL, right? And a lot of this, some of this was actually inspired by a blog post written by a good friend and colleague, Mark Callahan, who discusses, Postgres and MySQL compatible databases. But anyways, let's keep going. Let's keep going forward. So a few points on the compatibility levels. The first one, the compatibility levels on why these are the kinds of compatibility to think about, is that every new database adoption follows a natural curve, right? Like people think about how to adopt a new database in the following steps. The first step is they want to go and explore the database. What does it really have? What does it do? How does it work? How can I map it to things I know from my prior database experience or what I need from my application? And that requires wire compatibility, because otherwise you're spending way too much time trying to figure out what's in the database, what tools to use, how do I build a simple application, and so on, right? Then you want to build and run a basic simple app, and you want to use a few simple tools in order to get this application running. And that requires syntax compatibility. Otherwise, you're spending, again, a lot of time trying to map what you want to do. You're trying to figure out how to get it done, right? And then when you start going into running more and more apps, invariably you get some complicated apps, some apps that push the boundaries of whatever is supported by the simple subset of Postgres. Then you're starting to look at feature and runtime compatibility. And once you're able to run a good chunk of apps that are some of which are reasonably complex, and you have the performance and the confidence, you can now switch to this new database as the default for those classes of applications that database targets, right? So this is the natural curve, and the framework for compatibility follows this natural onboarding curve. Now, the second thing to realize is your degree of compatibility is not all or nothing. It's not like you are not compatible or you're fully compatible. You can be a database can have high compatibility, moderate compatibility, or low compatibility for each of those levels, right? And lastly, we already called this out, but if you're runtime compatible, which means your application that runs against Postgres can run against this database, then it means you need to have all the other forms of compatibility. So in other words, your runtime compatibility score cannot be higher than any of the others, right? It's going to be the lowest of all the others is going to be your runtime compatibility score. Okay, so again, without much ado, let's look at how the different databases, the 4 different databases we talked about, which are cloud native databases and support PostgreSQL, stack up in this framework, right? And we will take these databases in the order in which they were previewed or released or started to get built or so on and so forth, right? So 2012, Google Spanner made its debut, and the paper came out and we knew how it worked. Well, it has moderate wire, and Google Spanner just recently, right, as of October, as we talked about, released a PostgreSQL API for their database so that you can interact with Google Spanner using Postgres. And don't worry, we're going to go into the details of how that works and what they did and so on. But this is just like the gist, right? It's moderately wire protocol compatible, and it has low syntax compatibility, equivalent features, and runtime compatibility is therefore low. It's the minimum of the other 3, right? CockroachDB, the database project, started in 2014 and the company started in 2015, has high wire protocol compatibility and syntax compatibility, but low equivalence of features and therefore low runtime compatibility, right? Amazon Aurora PostgreSQL and YugabyteDB have pretty high compatibility across the board, right? And again, before you think like, how does this work out? These are not things that happen by accident. This is almost a design decision on the part of the databases in what they want to accomplish. So these are not per se limitations of the database, or they turned out to be limitations. This is how the databases were built, and this is the purpose that they're going for, right? Like this is really the statement of purpose for why they built the database and their design principles. Okay, so let's go into each of these databases now and look at what does compatibility mean to them, what were their design points, why did they build the database the way they did it, and how do they accomplish PostgreSQL compatibility, right? Like we'll talk about some of these. We'll talk about why, especially the ones in the moderate and lows, why are they moderate and low? And then, we'll use a example scenario to actually go through how would you implement, Dash. We'd use one of these scenarios to go through how you do it in the 4 databases and how this compatibility ties up together, right? So that's going to be the structure for the rest of the talk. Okay, so first let's look at how these databases built PostgreSQL compatibility one at a time, right? The first up is Google Spanner, PostgreSQL API, the one that was most recently released, right? Before we go into the PostgreSQL API, just a quick word on what is Google Spanner, right? Like a lot of you folks may know, but for the rest of the folks, Google Spanner is Google's globally distributed database service. It's a transactional database service. It is the first ever horizontally scalable relational database. And it was built for internal Google use cases. Google has a long lineage of extremely incredible databases they built, starting from Bigtable to, F1 and Megastore and Spanner and the whole lineage of databases that they built. But Spanner is the horizontally scalable and shared nothing but transactional database. It started out with a proprietary API, and then they added a SQL API, but it was a custom ANSI SQL compliant API. And Google Spanner found that the adoption was not as good, even with a ANSI SQL compliant, but a custom SQL API. It's a new SQL dialect. And hence they recently added, which is as of last month, the PostgreSQL API. Now, folks may say if it's SQL, it's good enough, right? But this move by Google Spanner actually shows that it's not sufficient to just be SQL. You actually need a flavor of SQL that everybody understands, because the fundamental questions that people are asking are, how long is it going to take me to understand how to use this thing? And how do I know it's going to work for me through the future for my next set of applications? It may work for my first app, but will it work throughout, right? So those are some of the questions folks are thinking about, and this is, Google Spanner validates that. Now, what is the design point for PostgreSQL compatibility in Google Spanner, right? We're going to call out what they did and whether it's like or unlike Postgres, right? The first thing that Google Spanner does, straight up from their own definition, is it's highly available, horizontally scalable by design. So that's what it's built for. If you have an application that, where you don't, availability with integrity of data or scale, right, on demand by adding nodes is not a concern, well, then this is not an ideal database to pick. But that is unlike Postgres. Postgres is not highly available, and it's not horizontally scalable by design. Right. And Google Spanner does distributed query processing. So if you send queries, if you have a set of different nodes that form a cluster, you could send the queries to any of the nodes and they will all process queries. And it has a distributed storage layer as well. So all of your storage is spread across multiple nodes, and that whole unit behaves like a single logical relational database, right? And both of these are unique and different from how PostgreSQL works, right? In PostgreSQL, both the query processing and the storage is on a single node. Like we said, they started out with a custom SQL dialect, but now PostgreSQL is being added as an alternate API to interact with the database, right? And we'll see why the custom SQL dialect is important. So now, we already know our Google Spanner already had a set of API exposed using a custom dialect. Now, the way they added Postgres compatibility is they added a layer that transpiles or converts at runtime the Google Spanner PostgreSQL API, the PostgreSQL requests coming in, the PostgreSQL statements into equivalent Spanner statements. So they already had a version of SQL. This new version converts it into effectively the functionality exposed for the existing SQL, right? And this process of converting at runtime is like, think of it as a translating compiler or a transpiler, right? And this transpiler is called PG adapter, right? If you look at the example on the right, the diagram, what you see is that you have an application. In this case, it's pSQL. It talks to the PG adapter, which is the transpiler. The transpiler receives, a Postgres wire protocol compatible, statement that Postgres understands, and below it converts it into a gRPC based request that Google Cloud Spanner understands, right? So it just translates it. The PG adapter itself runs right next to the application, right? So it runs as a sidecar right next to the application. So the application talks to the PG adapter that sits right next to it. PG adapter converts it and sends it to the database, right? Now, overall, this approach ends up, and its current implementation ends up with a low PostgreSQL compatibility overall, right? And let's look at why. But before we go there, let's also quickly look at what does it mean for a developer, right? It means that a PG application. So if you have a Postgres application, then it may not run as is against Google Spanner. And if you're a developer that has used Postgres extensively, you may need to understand what is not supported, what is the runtime semantics of what is supported, what are workarounds for missing features, what do you have to re-implement in your application layer, and so on and so forth, right? And this is not something that's like, this is actually the design point of the database, right? If you look at Google's own, I mean, there's a source link below, but it says that, familiarity and portability are the goals, not compatibility. And they're focused on a bunch of stuff. But if you really want to move applications that have a high level of compatibility or use a lot of the Postgres API, or you want familiarity with Postgres, then you should go to a different database, which is Cloud SQL in this case, right? Now, why would it have low compatibility? Why do we say it has low compatibility, right? Like, firstly, let's look at the different levels again. Again, we're not going to look at runtime because in this case, runtime is just the minimum score of the other three. But in terms of wire protocol compatibility, right? This is again from the Google's own documentation. The following is not supported, right? So functions, the copy protocol, prepare statements for describing prepared statements, SSL, which is like, encrypted connection, like TLS encryption and connections with that, and pSQL meta commands other than the five of them listed here, right? Now, the key thing is some of these things are important, like such as the copy command and some of the meta commands specifically, and SSL will be important. But, like, I didn't go too deeply into how you implement SSL on the Postgres API on Google Spanner. It's still like, invite only beta preview. But, assuming that all of this is something you can get past, and there's a reasonable workaround, and the meta commands are reasonably covering the first set of commands you need, but there's still some other commands that are pretty useful. So we're just going to go with a moderate compatibility here. It cannot be highly compatible because, in that case, a lot of this should just work out of the box, right? And if you look at syntax compatibility, I think here, it doesn't support a number of PostgreSQL data types. Again, the reference from the Google documentation is right below, but it doesn't have the serial data type, which is used to implement sequencing and auto assign IDs. It does not support date, timestamp without time zone, character, interval, and array, right? And some of these, specifically the serial data type, character, date, and timestamp, are actually quite common in practice. So it makes syntax compatibility very difficult, because if your application has any of these types, it's not going to work with Google Spanner, and you'd have to change, right? So it starts to become low, and some of these may be easy to add, but some of these not so much, because now how do you encode the timestamp? All of those start getting into the details of how you build those features. Okay, now let's look at the next bucket. So we looked at wire protocol, and we said it was moderate, and the syntax compatibility was low. In terms of feature compatibility, again, this is also from the Google documentation. It says that a lot of these features are missing, right? And specifically features such as triggers, the sequences, various types of privileges, your concurrency control, partial indexes, extensions, foreign data wrappers, UDTs, all of these are extremely common and very powerful Postgres features, right? So it does make it low in terms of compatibility, because what this means is if you either want to use one of these or you have an application using one of these, you'd have to change it or find a workaround or build it on your application side or so on and so forth. Okay, so let's go to the next database. So hopefully that gives an idea of how Google Spanner approached this, what their design goals are and what they're trying to do, and therefore what the result of compatibility is. And of course they have Postgres compatibility, but what does it mean, right, is really the question here. So let's look at CockroachDB, right? CockroachDB is a NewSQL or a distributed SQL database for OLTP workloads or transactional workloads. It's cloud native. It's PostgreSQL wire compatible. It's wire compatible. It is rewritten, the database itself is written in the Go language, right? And it's available as, it's software that you can see. It's open source, but with some features that are closed, like it's open source with a restrictive license and some features that are enterprise only, right? And it's also available as a fully managed cloud service. So now let's look at the design point for Postgres compatibility in CockroachDB and what it's trying to achieve, right? So very similar to Google Spanner, it is highly available and horizontally scalable by design, and that is unlike Postgres. It's a very similar design point as we talked about before with Google Spanner. And also like Google Spanner and unlike Postgres, it does distributed query processing and it has a distributed storage layer. So you have a cluster of nodes, the set of nodes behave like a logical relational database. All of the nodes can process queries and their storage is spread across all of the nodes, right? And it is PostgreSQL wire compatible and somewhat syntax compatible, right? And let's go into how it achieves this. Well, PostgreSQL is written in Go, so it re-implements the PostgreSQL API in Go natively. So Google used a transpiler approach which converted. So in this case, it's built natively into the database, but it's rewritten in a different language, right? Now, it does support PostgreSQL wire protocol, and it does a good job of trying to support most of the PostgreSQL syntax. It is not feature or runtime compatible, but even with respect to syntax compatibility, right, it is very difficult to achieve a very high degree of compatibility by re-implementing an existing database, right? And that's just like axiomatic because Postgres represents 30 plus years of development, and it's difficult to compress time and to have the level of accuracy where the usage is exactly the same verbatim, right? So there's going to be gaps, and we're going to look at, there's going to be some gaps, like especially with respect to the syntax compatibility, but those we're just overlooking because it's not going to kind of pose that much of difficulty in terms of people getting onboarded with the database and starting to use it. Okay, but first, what does this mean for developers, right? Once again, just like Google Spanner, very similar design points. So a Postgres application may not run as is, and a developer that's familiar with Postgres may need to understand the runtime semantics, the workaround features, what are the missing features, what are the differences in the runtime, so on and so forth, right? And once again, from CockroachDB's own docs, it does say that it does not support some of the PostgreSQL features or behaves differently from PostgreSQL, and for a variety of reasons, right? And it's got pages and they have good documentation on what's different and so on and so forth, right? So, okay, so we already said that CockroachDB is wire compatible and is does a pretty good job of being syntax compatible. So we'll just call it really high, even though there may be some surprises, but we'll just ignore those. The next bucket down is feature compatibility, and here's where it becomes low. Because again, from the Cockroach documentation, it doesn't have triggers, stored procedures, functions, events, user-defined functions, the full text search functionality. Some of the things like dropping primary keys you can work around, or XML functions. Not too many people use those right now. But column level privileges, the XA syntax, and there's some other stuff like row level security, table spaces, declare cursors, and so on and so forth, right? So the bottom line is a lot of these features are actively used by a number of users of PostgreSQL, and many ecosystem projects use them implicitly, right? So these become very critical in order to move any relational application that currently runs or a relational application that leverages the Postgres user set. So therefore, the score here is a low level of compatibility, because you'll have to figure out for each one of these how you have to go ahead and build your application and so on, right? Here's a quick note on runtime compatibility outside all of the stuff we've discussed that is common to both Google Spanner and CockroachDB. In terms of transaction isolation levels and how transactions behave, both of these databases only support the serializable isolation level, right? But PostgreSQL supports serializable, repeatable read, and read committed, and read committed being the default. So there's three distinct isolation levels you can choose from, and the default is read committed. And most of the relational databases that people are familiar with, developers are familiar with, and applications currently are running, and these applications get modernized, use Oracle, SQL Server, DB2, etc. They all use read committed as the default isolation level. So, just a note that you'd have to reason through, your transaction semantics and what happens on contention and so on and so forth. And this makes it difficult to, adopt widely if you're moving a large number of applications to one of these databases, or if you have a large number of developers that know how to use, existing relational databases. So just a note to think about. And I'll tell you this also based on a little bit of our personal experience at YugabyteDB. And I know we haven't come to that, but YugabyteDB is, again, and we look at the design point, but we had to add read committed into our roadmap and actually implement it. And we just released it simply because we kept hearing this feedback over and over, right? That it's not the default isolation. The default isolation level of PostgreSQL is not supported, which means it's difficult to be large scale, compatible with that database. Okay, let's look at Amazon Aurora PostgreSQL as the next database. And so what is it, right? Like, it is Amazon's fully managed relational database as a service. So note that this only works in the Amazon cloud ecosystem. You go to some other cloud, you don't have Amazon Aurora. But Aurora is MySQL and Postgres compatible as a database engine. It reuses a large portion of the code base, and it has shared storage, right? So the query that runs on a single node, but your storage makes copies across different zones. Okay, so let's look at the design point, right? Like, I think, and this will clear up what they're trying to do. The first thing they're trying to do is to make it crash resilient, which is, which Postgres is not. So that means that if you have a node die, your data should not get lost, and you should be able to bring up another node in some other location and still be able to recover from exactly where you left off with no data loss, right? So if you're deploying in the cloud in say a multi-zone fashion, and you have a zone outage, you should be able to preserve that data across different zones. So that's their the huge thing that they are adding on top of Postgres, right? And in order to do so, you need to distribute your data to other zones, and for which they do a distributed storage layer underneath, which is unlike PostgreSQL, which is a single node. Now, it is not horizontally scalable by design for writes or for reads. The reads are more like Postgres, where you can have a replica and read from a replica. The writes actually have to go through a single node, right? And so it's predominantly just single node query processing like Postgres. It is fully Postgres feature compatible, wire compatible, and it's almost completely runtime compatible. So your applications can barely tell the difference between the two databases, though there would be differences in terms of performance and so on, right? So how does it achieve PostgreSQL compatibility? Well, the way Aurora does it is it starts with the Postgres codebase. So it entirely reuses the Postgres codebase. And that means your application, when it connects to Postgres, still connects to the same code in the case of Aurora, right? The upper half of Postgres is the same. But it re-implements the storage subsystem, specifically with respect to how data files are flushed to disk, how your write-ahead logging is done, and how your crash recovery works, right? So this subsystem, the place where Postgres writes to disk, actually is changed in Aurora in order to distribute data across zones and recover from, copies and so on and so forth, right? And this means that because your upper half of Postgres is the same, your runtime semantics are preserved across all of the aspects, right? Authentication, authorization, query and syntax, and so on and so forth, right? Like your features supported and so on and so forth, right? I think Robert Kirby makes a very good comment. Aurora is not C extensibility compatible. Amazon refuses to support such extensions. Thank you for pointing that out. I think architecturally, there's probably nothing stopping it from doing so. I would imagine is what it feels like, but it might just be the complexity of supporting that along with the risk introduced by having somebody to inject code. But I think your point is fair that in the case of Amazon Aurora, it's a managed service, and if you're not able to use your C extensions, then what can you do, right? So I think it's a fair point. I think I will make the change. Thank you for pointing that out. It's pretty astute, um, okay, so I think that point that Robert makes, absolutely, but let's keep that in mind, but maybe still go ahead with the rest of the forms of compatibility, right? So what does this mean, right, for a developer? So it means that any application that uses Postgres can automatically run on Aurora, unless if unless you like for example in this case, if you have a C extension or something, but we'll ignore that. A developer with an inner working knowledge of PostgreSQL is instantly familiar with Aurora, and distributed storage subsystem may cause, because the underlying storage subsystem actually replicates data to different zones and so on, your runtime expected performance, etc., may change, right? You may have higher latencies, or some of your queries may have poorer performance, right? It's not an issue in some cases. In some other cases, you can modify your application a bit. And in the cases where it absolutely matters, well, that's not the design point for the database itself, right? And that's what their own documentation accurately calls out too, right? You can easily migrate MySQL or Postgres databases to Aurora. Kurt asks a question, why do I say that Postgres is not crash resilient? It is. Yes, it is, Kurt. If you think about, if the Postgres process crashes or the node crashes and is a blip, but if you think about a deployment where, you lose a zone or you lose a node permanently, then, the stuff that's on the Postgres subsystem would not be, you wouldn't be able to recover it because it writes to local disk. And if you put Postgres on top of an EBS type store, its performance drops quite a bit, right? And that's why Amazon actually went ahead and built Aurora, because the way the replication of the write-ahead journal is done and the way the data files are replicated is actually quite different in Aurora compared to their RDS solution. And RDS PostgreSQL is simply a fully managed service of PostgreSQL. So it's just take PostgreSQL, put it on an EBS, and give you, the resultant saying, okay, look, it's Postgres that's run for you, right? And that is not as crash resilient, and the time to recovery sometimes is very large. Your performance is slow, and so on and so forth, right? Yes, you can use the replication features built into PG, but that will often lead to more of a custom deployment where you have to reason about the data loss when you're doing the promotion from the, if you're promoting, if you have a, a primary and you have a replica and you're promoting the replica to a primary, you could lose some of the data. In all of these cases, there is zero data loss, and there is zero like the end user would not have, as a developer, would not have to think about building these type of solutions. And you're right, you can keep architecting, more and more sophisticated levels of deployments that make it that get you more and more features. But all of these would require a knowledge on the part of the app developer to say, where does it go, and so on, right? PG has sync replication. Again, great questions. But PG sync replication, does it come with availability? What are the availability trade-offs? What are the performance trade-offs? I think if you take a look at if you take a look at it holistically, right? Like what happens in PG replication when a node dies? Is it going to be, does PG replication wait for data to get written to all of the copies or just one of the copies? Or what happens if one of the nodes goes down? What happens if there's a partition, right? I think those are the things to really reason about as an end-to-end solution for a developer, right? So the idea is developers would want instant familiarity, but with the simplicity of deployment and running it and so on. So that's really the cut that I have been going for here. You're right. If somebody really likes PG, they can keep extending it and getting it to cover some of these other use cases as well, right? Like, I mean, that has a limit too, but it can cover a lot of the other use cases. So yeah, it's a fair point, right? Okay, so let's look at, yeah, somebody's asking for the copy of the slides and the recording. Yes, we'll put both of them out like we generally do that. So yeah. Okay, let's talk about YugabyteDB YSQL, right? Like the YugabyteDB API. Again, a very high level thing about YugabyteDB. It's a distributed SQL database for OLTP workloads, transactional workloads. Again, distributed and cloud native. It's PostgreSQL compatible. It has, just like Aurora, multiple APIs. Aurora has MySQL and Postgres. So similarly, YugabyteDB has multiple APIs. But for the purposes of this conversation, we're going to focus on YSQL, which is the Postgres compatible relational API. And it's fully open source and runs in any cloud, right? So, and with a managed cloud offering as well. Okay, so what is the design point for PostgreSQL compatibility? That should be YugabyteDB, folks, like it was a late night cut paste error. Anyways, so it's highly available and horizontally scalable by design, right? Just like Spanner and Cockroach. It's got distributed query processing and it's got a distributed storage layer. So cluster of nodes appears as a single database. Any node can process queries. Your data is spread across multiple nodes. Again, that's different from PostgreSQL. But like Aurora, it's full feature compatibility is the goal, and it's therefore very much like PostgreSQL in that regard. And it's nearly complete Postgres runtime compatibility is the goal. Again, note that, I mean, I'll mention this here, but we'll talk about why later. The degree of runtime compatibility that an Aurora can achieve, which itself is going to be a little bit lower than what Postgres can achieve, is going to be more than what YugabyteDB can achieve given its design point. So, PostgreSQL is the most compatible PostgreSQL database, followed by Aurora, followed by YugabyteDB. And that has to do with the fact that Aurora only distributes the storage layer, but processes queries through a single node, whereas YugabyteDB distributes the query processing as well, right? So, and we'll talk about some of the trade-offs when you do distributed query processing and so on. Yes, it says CockroachDB. It's a mistake. Thanks. Like I said, it was late night making slides. Okay, so PostgreSQL compatibility with YugabyteDB, right? How does YugabyteDB achieve Postgres compatibility? Well, just like Aurora, it reuses the upper half of PostgreSQL, but unlike Aurora, it only uses the query parser, planner, optimizer, executor, postmaster, like all of those things, which is like Aurora, but it re-implements the entire lower half. So the entire disk subsystem, the storage subsystem entirety, along with transaction processing and data sharding, all of that is re-implemented similar to Google Spanner, right? So, and so that means that a lot of the runtime semantics are preserved, like authentication, authorization, query and syntax and features, but some of the runtime semantics can change, right? And this depends on how you're running and deploying YugabyteDB. Are you processing queries in a distributed fashion across different nodes? Are you sending all the queries to a single node and just replicating data? So some of the finer grained degree of runtime semantics actually will change. For example, if you are truly doing distributed query processing and you want ACID semantics on your transactions, then you are going to see, you could see a higher degree of transaction conflicts, because your transactions, your various operations inside the transaction could take longer because they're now replicating and consulting other nodes. Whereas if everything is being done on a single node, you can get that done much quicker because you don't need RPCs in order to do some of the transaction processing. So it really depends on the feature, the way you use it, that you could see the runtime change a little bit, but that's for the good because that's what the database is trying to achieve, right? Okay, so what does this mean for an end application or a developer? That means that any application that uses PG automatically runs on, oh my God, it's full of typos, automatically runs on YugabyteDB. It should not be Aurora. And a developer familiar with PostgreSQL is instantly familiar with YugabyteDB. The query layer enables scalability and geo-distribution of data because your query processing is federated. And distributed storage subsystem may cause higher latencies, poor performance, again, very similar to Aurora. And this can get a little worse than Aurora if you're truly doing distributed query processing across faraway regions, right? So then your performance and design point of the application itself changes. But once again, that's what the database is trying to enable, right? Mike J has a question. Does YugabyteDB have a preferred load balancer to round robin the nodes? I mean, I'll give you two answers. As far as the load balancer, you can use any of the network load balancers that the cloud providers provide if you're putting it in a cloud. If you're putting it like on-prem, anything like an HA proxy, any of those, any standard load balancer would work. However, that said, we are working on a smart driver. We already have it for Java, so you can check it out. you don't need a load balancer when working with Java, with the JDBC. YugabyteDB's version of JDBC, which is a smart driver, it can connect to a single node and discover all the other nodes and do automatic load balancing to round robin, right? So this gives you the functionality of eliminating the load balancer and actually being cluster aware and topology aware and those type of things. All right, so why does all this matter? We talked about a whole bunch of stuff. By the way, I think a comment that I mentioned before, I want to tee it back up. Both Aurora and YugabyteDB support all the three levels of transaction isolation that Postgres has, right? And it's like, that makes it a much easier. Like I said, Yugabyte only supported two, which was serializable and repeatable read. And we got enough asks for read committed being the default that we said, you know what, if enough people are asking for it, it probably does matter. And so we did add that, and we just announced it in our most recent release. So we do have all three. The default for Yugabyte though is still a repeatable read, and we're still thinking through whether we should change it to read committed or not. But just a heads up on the transaction isolation levels also. Okay, so let's run through, it's going to be just one example because we are close to time. So let's take a very common example scenario. You want to auto update a row timestamp. So in this example, you have a users table, you have an ID, name, some details, but you have an updated timestamp. That's really what we're going to look at. And what you really want is, when does this timestamp, every time somebody updates this row, you want this timestamp to get updated. So very simple paradigm. What would a PostgreSQL developer do? If you're PostgreSQL compatible, this is how a PostgreSQL developer thinks. You'd say, okay, the first thing to do is to go create a function that would update the time. And I can put any logic inside. I can put a conditional logic. I can do whatever I want. I have full flexibility, but the simplest cut paste approach, cut copy paste from Google approach, it requires, okay, I'm going to cut paste this. I'm going to change the field name to the actual field name that I have, and I'm good. And I'm going to attach it as a trigger to the table. So I'm going to create a trigger name, and I'm going to say, before you update users, you execute this procedure, and I'm good, right? Now, this works on the databases that are runtime compatible. It does not work on Google Spanner and CockroachDB, right? So as a practical developer, this is roughly what you would do. Of course, getting started, you'll figure it out with all the databases. You now want to go build your application. This is the first scenario you're approached with, right? So now, what would you do with Google Spanner? Well, after a bit of Googling, I found this, which is like, you write a commit timestamp using a DML statement, using the pending commit timestamp function, and it selects the appropriate timestamp, right? So you say update performance is set timestamp is to this function with some where clause, right? Okay, but it's still an explicit concern for the application, whereas this used to happen implicitly, right? Is something you have to now add to your update statement. But fine, it's maybe not the end of the world. It's fine. Let's keep going forward, right? But after you probably would learn this the hard way if you're like me and don't read the documentation fully and just go and implement it, and then you're debugging for a bit. But anyways, so you notice that there's a caveat about when you can use it, and whether you can refer to that timestamp after you use it inside a transaction and so on. And at this point, it makes it difficult to know, is it going to work for all the applications? Is this something to worry about or not? Like, is this the semantics that Postgres gives, or what can I get with Postgres? So you start worrying about a bunch of this type of stuff, right? And similarly, I try to do the same thing for CockroachDB, and I spent a bunch of time trying to figure out like what the equivalent feature is, but this is either not sure if it's supported, or this is, I was still a little confused about it. So this is at least honestly what I found. And again, no knock, we have bad documentation on our side too. So I'm not like calling anybody out on it, but it's just an exercise in walking a mile in the developer's shoes, right? So I saw this from one of their GitHub issues. This is what I hit. The issue was still open. And it said like, the guy originally said something, and then a couple of years ago, something. And then there was like another comment there which said, they're going to remove this in favor of something. And I kept Googling for, a bunch of stuff, and finally found, this on a DZone article, which said it actually talks about this exact problem. The article is well written, and it talks about how you can use CRDB internal MVCC timestamp as a hidden column to select, and it has some timestamp, right? Like, I don't know what the MVCC timestamp represents. Does it correlate to time? Does it not? How do you convert it? It starts getting more complicated, but the other things are, it's not runtime compatible. So you have to do a bunch of changes in how this works. it's unclear if there's a real equivalent feature because like, I may want update after update before, I may want some conditional logic and so on. But the other thing was, if it has an internal in the name, I don't know if it's a good idea to use it for production. At least that's just me. So, that's another thing. And is this overall feature going to work for all of your applications, right? So these are some of the questions I was left away in both the cases, right? Spanner and Cockroach. And if I'm purely thinking about an end developer's point, I'd be like, okay, at what point is this going to get me, or so on, right? So there are many other scenarios, and this is just one example and a relatively simple one at that, but you just need to know that the database will work, right? And the reason why people like Postgres is because they know it works. It's been used a million times in scenarios like these before, and a search in Google will give you all of those answers and how to cut, paste, and what kind of code to write, right? So there is a value to that. There's a huge value to future proofing. Now, I'll take a few questions, but I just want to wind down. So remember that the only 100% PostgreSQL compatible database is PostgreSQL, right? Every other database, if it is 100% PostgreSQL compatible, you are going to end up with Postgres, and there's no use rebuilding Postgres, right? Like, it's already there and it's free too. So the rest of the DBs that are trying to achieve something, the higher the Postgres compatibility, the better, right? So the more you can push this, the more you get out of the like your intended audience, the more easily they can adopt it, the less mental friction there is, right? So, yeah, thanks for that. Again, I want to take a few questions before I sign off. I think there's a question that Christoph asks: is there a way to use a dedicated low latency network for the storage layer for the on-prem install? Yes, Christoph, you can use a dedicated low latency network. I think the results should just be transparent, because at the end of, if you're talking about non-TCP style networks like RDMA right now, no. But again, these are things that'd be great to add as GitHub issues and get a conversation going. But if it's more like a dedicated low latency TCP based networking stack, then yes, the results should be transparent and you can use it for the storage layer, right? So it just depends. And there's a couple of ways to doing that. You can have a SAN or a NAS device that does the disk storage with some redundancy attached to the database, or you can have the different nodes themselves be connected using the low latency network, and you should see the effects immediately there as well. Okay. I had a few other questions. I'll just read them out, but if folks have other questions, please feel free to post. Oh, wait a minute, I'm missing all the questions. It's auto scrolling. Okay, there's a lot of other questions. Hold on. Mike J asks, does YugabyteDB support Rocky Linux 8 deployments? I don't know, but we would love to. So please jump into our Slack and ask the question, or even better, just open a GitHub issue against us, and I think we'll get back to you. Kurt says the whole concept of PostgreSQL compatibility is generally a misnomer. Things like extensibility of data types, operators, and access methods indexes are generally not supported by all these variants. Well, at least I can speak about YugabyteDB. Extensibility of data types, operators, and access methods, a lot of them are supported by YugabyteDB. The index types we don't have right now, or that we don't support, are, one of them is intentional and one of them is more like work in progress. We don't support the gist index for geospatial types, and that's just something that just work that we have to do, and we will support it. The B-tree based index is something we don't support because we are a log structured storage system, and LSM is what we support. So we map B-tree to LSM, but we do support extensibility operators. You can do, I think one of the questions that Bob had, which is also pretty similar to the direction that you're asking about, is the SPI, right? The server programming interface. And that's something that we support, and you can put your C functions in there. So we do support the whole enchilada, right? So those are all in scope, and something we have foreign data wrappers and so on and so forth. And a number of the extensions, at least at the query layer, do work. So, PG trigram, PG stat statement, PG audit, a lot of those work, right? So we've taken a lot of care, Kurt, to push the limits to how close we can bring it to Postgres compatible. But, like I said before, if we are 100% Postgres compatible, then we're just Postgres, right? And there's no point building Postgres, it's already great. So we are trying to take the world to be in the Postgres ecosystem, but extend this towards scalable and continuously available and geographically distributed workloads where you can treat the database across a set of nodes that, irrespective of the deployment, as a single logical database. Diana asks, what about the cost and license for Yugabyte? Just like Postgres, we are compatible on that front too. We are a 100% open source Apache v2. And yeah, the commercial side only is around the DBaaS and getting the operations to run easier. So the database itself with all its features is completely open source. Mike J asks, is the PG layer still 11.2? It is, but we are actively working on the rebasing to PG 13. And this should be out pretty soon, right? So we do intend to move up to newer versions of PG, but in the initial focus has been on catching up with PG functionality, and now we are rebasing to newer versions of PG. Ilsen says, how to get help? I'm trying to install and import data from Aurora PG without success due to timeouts. We would love to help you out. Like right on the screen now, there's a community Slack, yugabyte.com/Slack. Please join that and we will help you. Kurt says, I mean, user-defined extensibility of types, operators, and indexes. Yes, might be in response to the conversation we were having, but I didn't get the point, Kurt, but maybe we can chat offline. Just grab me on the community Slack or any of the other social channels, and happy to talk about it. Like it's maybe something that even I'm not aware of or I don't understand, but I thought we support a lot of the, like we do support UDTs and operators and so on and so forth. And so yeah, I think would like to talk about it if there's a detailed point. Ilsen, yeah, I'm using the Terraform image. Yeah, I think we would love to help you. So please jump on our community Slack. We're pretty responsive and so on. Okay. Raj says, can you please share the URL to the article you mentioned on compatibility? I'm not sure which article. I'll share the whole deck. Will be out, so you should be able to see and reference the URLs below. But I'm writing a blog post on this, which should also be out soon. So all of this will be available in textual format also, so you can read it, right? A couple of other questions. Again, I'll cover them quickly. I think Bob had sent in a question, which is for my application, which involves an implicit graph structure, but currently avoids a graph database implementation. The with recursion style of Postgres CTEs, common table expressions, is required. And yes, that's something that we do support, as does Amazon Aurora, right? Like, so they're both runtime compatible. There was another question about Yugabyte not supporting PostgreSQL listen notify, but relying on CDC. And how do you, so is there a way to only get like the low volume changes or something, right? So I think, and Bob does note that low volume CDC could be handled with triggers. Yes, that is true, but there is overhead and complexity. The reason we're not supporting listen notify is because it breaks the fundamental distributed paradigm. A listen notify on a single node Postgres is just the changes on that node. Listen notify on a distributed Postgres gets worse as you add nodes, and we try to avoid that paradigm if we can, right? So our aim would be to support push downs and our aim would be to go and push down the filters into the change data capture stream, so you can selectively get rows. I think that would be the preferred approach. Okay, email's incorrect. Can somebody from the Yugabyte side please help Ilsen? Or just, okay. I think yugabyte.com/Slack should work, but if somebody can get back with the right Slack URL, that'd be great. And I'll find that for you, Ilsen. Diana says, I understand there's no global index on partition tables. Then what is the alternative? Yeah, I think this is, implemented in Postgres 13, and this is something that we're looking at, global constraints. So we are working on this. So please stay tuned. Again, if you would love to understand the details. So if you could open a GitHub issue against us, would love to interact with you on the details. Ilsen, an alternative is just to go to our GitHub and create an issue, and we'll get back to you. Okay, Anonymous says, so I'm guessing it's about supporting table value parameters. similar to SQL Server to pass the data to stored procedures? Yes, you can use the table, like you're talking about the $1, the variables that you pass in, right? So yes, you can create a stored procedure or a user-defined anonymous block, whatever it is, and you can pass in runtime variables inside and so on. So it does support stored procedure execution. It supports all the flavors of stored procedure execution that PostgreSQL supports. So that's the PLPG SQL and the C functions, SQL functions, etc. All of those. So yeah. Okay, we're a couple of minutes over time, folks, but great questions. Thank you, everybody. Once again, please join our Slack or open an issue on GitHub if you're not able to join Slack, and we will figure out, how to get you in. Thank you.